acceleration. So what we do is we write the total length of the thread in terms of these displacements and differentiate it twice to get relation amongst various acceleration. Now let me explain this concept further. So as you can see here we have a pulley system. One end of the thread is attached to the ground and it is immovable, and to the other end a block is connected, and this pulley is moving upwards with acceleration A, and suppose the acceleration of this block is B. So now we want to find out the relationship between the accelerations A and B, that is the acceleration of pulley and the acceleration of block. So let's take this ground as the reference point. So let's say that the length of this part of the thread is x and the displacement of the block with respect to this reference point is y. So the total length of pulley will be L is equal to x plus this length, and this length is nothing but x minus y. So total length will be x plus x minus y, or it is equal to 2x minus y. So now what we can do is we can double differentiate this length. Since L is constant, its differential will be 0. So differentiating it twice will get 0 is equal to 2 into d square x by d2 square plus minus d square y by dt square. Now y is the displacement of this block with respect to this reference point. So the double differential of y will give the acceleration b, that is how fast the block is moving away from this reference point. Similarly, the displacement of the pulley with respect to this reference point is x, so the double differential of this displacement will give the acceleration of the pulley with respect to this reference point. So we can write d square x by dt square as a, that is acceleration of pulley, and d square y by dt square as b, that is acceleration of the block. So we have 0 is equal to 2a minus b, or b is equal to 2a. So the acceleration of block is twice of the acceleration of pulley. Now let's see one more solved example. In this example, a force F is applied on the object of mass m as shown in the figure. We'll see the figure in a few moments, and we need to calculate the acceleration of mass small m. Now let's see the figure. So in this figure, a force F has been applied to the block of mass m, capital M, and we need to find out the acceleration of block of mass small m. Now let's see what are the various forces which are acting on these three blocks. So first we'll assume that the acceleration of block of mass capital M is a, and the acceleration of the block of mass small m is c, and the acceleration of block of mass m dash is b. So as you can see from here, the tension in the thread is T, and since it is a single thread, so the tension will remain throughout the same. So the forces acting on the block of mass m dash is tension T, T, T and T. So the total force which is acting on block of mass m dash is 4T. Similarly, the tension force acting on the block of mass small m is T, and the force acting on the block of mass capital M is 2T. So now we can write the equation of motion of for these three blocks. So let's find out the equation of motions for the three blocks. So first we'll take the small block of mass small m. So the net force on this block was T and its acceleration was c. So for this block the equation of motion would be T is equal to minus mc, because the direction of acceleration and the force applied is opposite, so we have included a minus sign here. Similarly, for the block of mass capital M, the net force was F and 2t and its acceleration was a, so we can write F minus 2t is equal to capital M into a. And for the block of mass capital M dash, the net force acting on it was 4t and its acceleration was b, so we can write 4t is equal to minus m dash b. Here again the direction of net force and the acceleration are opposite to each other, so we have added a minus sign here. So these are the three equations of motion. Now let's find out how can we use the thread constraint. Now as you can see here that the total thread length is, this is y, so this will again be y, this is also y, and this is also y. This is x, so this will again be x. So the total thread length L is 4y plus 2x plus z. Now if we double differentiate this equation, we will get 0 is equal to 4 into d square y by dt square plus 2d square x by dt square plus d square z by dt square. Now you can write 0 is equal to, now d square y by dt square is nothing but b, so 0 is equal to 4b plus d square x by dt square is nothing but a plus 2a, and d square z by dt square is nothing but c. So this is the relationship between the acceleration of these three blocks, that is 4b plus 2a plus c is equal to 0. So we'll keep in mind this thread constraint. Now we have these equations, that is 4b plus 2a plus c is equal to 0. Now if you recall that the force acting on the block of mass small m was T and its acceleration was c, the net force acting on the block of mass capital M was F minus 2t and its acceleration was a, and the net force acting on the block of mass m dash was 4t and its acceleration was b. So here we had the various equation of motions as t is equal to minus mc, f minus 2t is equal to ma, and 4t is equal to minus m dash b. So these are the three equations. Now from equation 1 the value of c will be t by minus m. Similarly from equation 2 the value of a will be f minus 2t by capital M, and from equation 3 the value of b would be 4t by minus m dash. So we can put the value of a, b and c in this equation, that is the equation which we derived from the thread constraint. So we can write 4 into b, that is 4t by minus m dash, plus 2 into a, that is f minus 2t by m, plus c, which is t by minus m, is equal to 0. Now from this equation we can get the value of tension, that is T, in terms of capital M, M dash and M. So this is straightforward. We can get the value of T from this equation. This is equation 4. Now once we get the value of equation T, we can find out the acceleration of a block of mass small m, which is c, and c is given by t by minus m. We already have the value of t from this equation, that is equation 4. Now we can also get the value of c, which is the acceleration of the block of mass small m. Now we'll see how we can solve some pulley system using U-axis theorem.